Our lesson today is about Hooke's law. Objectives. At the end of this presentation, the student should be able to draw the graph, the variation of the length of the spring L as function of the mass of the load M in case of compression. Draw the graph, the variation of the tension of the spring T as function of its compression X. To find the stiffness constant of the spring graphically. Equilibrium of a body. The two forces acting on the body S are weight and tension. When the body is in equilibrium, the condition of equilibrium is W vector plus T vector is equal to 0 vector. The sum of the forces is equal to 0. W vector equal minus T vector. The forces have the same line of action and opposite directions. W equal T. The two forces have the same magnitude. Compression of the spring. If we place a spring in a cylinder, the initial length of the spring is L0. L0 is the length of unloaded spring. If we place a load of mass M on this spring, then the length of the spring becomes L. L is the length of loaded spring. The compression of the spring is X. X is equal to L0 minus L. Keep in mind, to convert from centimeter to meter, we have to divide by 100. And to convert from meter to centimeter, we have to multiply by 100. The variation of the length as function of mass. The initial length of the spring is 20 centimeter. If we place a load of mass 100 gram on the spring, then the length of the spring decreases and becomes 18 centimeter. If we increase the mass to 200, the length becomes 16 centimeter. If we increase the mass to 300, then the length becomes 14 centimeter. Then, the initial length of the spring is L0 equal 20 centimeter. The forces acting on each load are weight and tension. According to condition of equilibrium, W vector plus T vector is equal to 0 vector. W vector equal minus T vector. And W equal T. To complete the table, mass in a gram, 0, 100, 200, and 300. Length of the spring L in centimeter, 20, 18, 16, and 14. To find the mass in kilogram, we have to divide by 1000. Then the masses are 0, 0.1, 0.2, and 0.3. Tension in Newton. Since the body is in equilibrium, then the tension equal weight. Tension equal M times G. Then the values of the tension are 0, 1, 2, and 3. Compression of the spring, X. X is equal to L0 minus L. Then X in centimeter, 0, 2, 4, and 6. The variation of length as function of mass. If we draw a graph, the variation of the length of the spring L in centimeter as function of the mass of the load in a gram, then the graph is a decreasing straight line. The intersection between this straight line and the y-axis is L0, or y-intercept is L0. To analyze the graph, when the spring is unloaded, the length of the spring is 20 centimeter. As the mass of the load increases, the length of the spring decreases. To find stiffness constant of the spring, K. If we draw a graph, the variation of the tension of the spring as function of the compression of the spring X, then the graph is a straight line passing through the origin. According to Hooke's law, T equal K times X. To find the stiffness constant of the spring X graphically, K equals slope of the straight line equal T minus T0 over X minus X0. Since the straight line is passing through the origin, then T0 equals 0 and X0 equals 0. Then K equal T over X, where K is in Newton per meter, T is in Newton, and X is in meter. To find K of this graph, K equals slope of the straight line. Graphically, 1t is equal to Newton, x equal 4 centimeter. To find x in meter, we have to divide by 100. Then x equals 0.04 meter. Then k equal t minus t0 over x minus x0 equal t over x equal 2 over 0.04 equal 50 Newton per meter. Thank you.